Okay, so lesson 9.5, as you can tell by the title, is all about graphing trig functions, and we're going to break this up into two parts because today we're just going to focus on sine, cosine, and tangent, and then in another follow-up lesson we'll talk about the reciprocals of those. So let me just get right into this, and let's talk about, first of all, the parent functions for sine, cosine, and tangent. Some important information about these parent functions. So we'll start with the sine function. Theta, of course, represents some angle. And by the way, if I haven't already said this, you definitely will want your unit circle to refer to as we go through this lesson. Okay, so first of all, when you do the graphs of sine, cosine, tangent, you're always going to draw your own little, it's like an XY axis, but actually this horizontal axis that we typically refer to as the x-axis, it's going to be the theta axis. Because on this horizontal axis, we're typically going to put these degree measures. Just think about working your way around positive direction around the unit circle, and the measurements for those quadrantal angles. Something like this. All right. So we'll fill in this information kind of as we go. I'm going to start with this word called amplitude. Amplitude, first of all, one of the common real-life ways that we see the sine function is the sound wave. And you can think of amplitude basically as the increase or decrease in the volume of the sound. So the way we determine amplitude for these functions is we look for any number in front of sine. And in this case, obviously, it's just an understood 1. So amplitude will be marked on what we call the y-axis. And for an amplitude of 1, it's actually a full distance of 2. If you have an amplitude of 1, then you make a positive 1 mark and a negative 1 mark, but the total distance is 2. Okay? Now on your unit circle, let's just make our way around it, starting at 0 degrees. That's where this would be on my graph. What is sine 0 degrees? Okay, so the sine graph goes through this origin point, 0, 0. Okay, let's go up to 90 degrees. What is sine 90 degrees? We're just inputting 90 in place of theta. All right, so input 90, output 1. What is sine 180 degrees?
0.
That was my son. Okay, sine 180 is 0. What is sine 270? Okay. And then all the way back around to sine 360, we're back to 0. So the parent sine function always takes this shape. It's a curve going through these points. I missed that one. And now that we can see the graph, now let's fill in some information about sine. The domain for the sine function is, as you can tell, along the theta axis, the horizontal axis, we're going to have all real numbers. I'll just say it like this. The range, however, will extend from, it's like we have this invisible dotted line, positive 1, and then another one down here at negative 1. We do not go out of those two. We stay within that boundary So we would say the range would be all y that is described in this way. Interval? You can use interval notation. And it's a bracket. Okay, we've already talked about amplitude, and we'll talk more about that when we talk about transformations of these parents, but you can always get amplitude by anything multiplied in front of the trig function. And so for the parent, the amplitude is 1. And remember what period refers to from yesterday's lesson? Okay, it is in this case 360 degrees because one complete cycle, it starts to repeat that cycle once it gets to 360 degrees. All right, so that's the parent sine function. So now let's talk about the parent cosine function. So once again, I'm just going to label. Most of the time, this is the way you will label the horizontal axis. And once again, the parent cosine function also has amplitude 1. And we'll label this as the theta axis, theta being the input. So as we work our way around the unit circle, starting at 0 degrees, what is cosine 0 degrees? 1. So you notice a big difference between sine and cosine graph. Sine always goes through the origin. Cosine has a y-intercept of 1. Okay, and then cosine 90 degrees, 0. Cosine 180, -1. 270, 0. 360, +1. So the cosine graph, I'm going to erase this dot because that was for sine. The cosine graph will do this. Okay, so domain and range are the same as what we saw with sine. And if you want to use interval notation, that's fine. Amplitude is also 1, and the period also 360 degrees. All right, now let's jump over to tangent. Tangent's quite a bit different because there are certain, as we make our way around the unit circle, there are certain places where tangent is undefined because we're dividing by 0. So I'm going to go ahead and mark the horizontal axis. Okay, so as you're looking at your unit circle, and you go around in a positive way, positive direction, where's the first place that tangent is undefined? Okay, so if it's undefined there, and this goes back to our knowledge of asymptotes, we're going to draw a vertical asymptote through 90 because we are not defined. Tangent 90 degrees is not defined. It's mathematically impossible. Okay, where else? 270. And where would the next one be? We don't see it, but 450. So what are you doing to get to the next one? You're just adding 180. So typically we don't, but I'm going to go ahead and put 450 here, or at least show another asymptote so we can get a pretty good look at what tangent looks like. And I'm going to jump over here and do a negative 90 as well. So here's tangent. Let's go to these other places like, what is tangent 0 degrees? 0. Okay. So here's what tangent looks like. Do you remember the cubic function? Y equals x to the third. Remember what that looks like? Kind of an S shape. Well, that's really a lot like what tangent looks like, because we're going to approach, but then we go through 0 because tangent is 0 at 0 degrees, and then we come over and we start approaching this other one. And we just do that within each of these separate intervals. At 180 degrees, tangent is 0. At 360 degrees, tangent is 0. And it's just this series of shapes like this over and over and over again. Going this way? Great question. What do you think would make this? Answer. Good job. Yeah, that's what cotangent does. And we'll talk about cotangent and secant, cosecant maybe tomorrow, but I don't think this is going to be on your test, or the reciprocals are not going to be on your test. These will be, but I think I'm going to put the reciprocals on the next test. And we'll have some review time tomorrow. Okay, so what do you think the domain is? We kind of touched on it earlier with something you said. Yeah, starting at 90, if you want to think about it, we'll say it like this. Theta cannot be 90 degrees plus 180 times, and we'll just say n, where n is some integer. So here's what I mean by that. If n is 1, then we're just adding 180 to get to 270. If n is 2, then we're adding 360 to get to 450. So it starts at 90, can't be 90, and then the other parts of the domain, we just keep adding 180 times some integer to get to the next asymptote. We increase n by 1. Or we could do negative 1 if we wanted to go in a negative direction. And let me just make this a little more clear. N is an integer. What about the range? Yeah, the range is all real numbers. What about the amplitude? Well, we could say that, but amplitude typically is a number, like we looked at with cosine and sine. So actually, for tangent, there isn't an amplitude. It just extends forever and ever and up and down. What about the period? Good. See, that's a big difference between sine and cosine as well. This pattern repeats every 180 degrees. Didn't we do that? There's cosine. They're the same. Okay, so you think you got the parents? Remember, these are where we start, and then other forms of these are made following some transformation rules. Okay, so let's start with sine. And what I've done here with these letters A and B, they tell us, again, we've already talked about amplitude, and then I'm going to show you what this letter B, when there is a number in front of theta, what does that do to the graph? Okay, so the directions in all of your problems, every single problem that you're going to do are worded, the directions are worded like this. Find the amplitude and the period, and then sketch the graph. Okay, so first of all, in letter A, I'm going to say the amplitude, and you can just put A for amplitude. The amplitude is 4. Whatever is in front of your trig function, whatever number, that's the amplitude, and if there's no number showing, it's understood to be 1. So I'm going to just make 4 little tick marks, both positive and negative. And you don't have to draw a dotted line, but you should understand that your graph should not go above positive 4 or below negative 4. That's the extent of the height, total of 8 units. Okay, well, to get the period, we're always going to start with 360 degrees. I've given you a little formula here to help you when you want to find the period, and that's a B. Didn't come out real plainly, but it's the absolute value of whatever is in front of theta. Well, it's understood in this case that theta is 1, so the period is just going to be 360 degrees. But we're going to look at some examples in just a minute where this is another number besides 1 and how that affects the period. What I've done here is, this is kind of helpful when it comes to sketching the graph, coming up with what we'll call theta, or in old language we would have said x-intercepts. And let me explain what this means. First of all, for sine, you're always going to have this as an intercept because that's where sine starts. We looked at that with the parent. And then if you want other intercepts, just take the period, which we found as 360 degrees, and multiply by 1/2. And what is that? Okay, so I know when I sketch my graph in just a minute, I should be crossing 180 degrees, and then finally, so this means 0 will be an intercept, 1/2 times the period will be an intercept, and whatever the period is will also be an intercept. And for this, I'm not sure that you really need that, because this is going to look a lot like the parent. It really is the parent, but it's stretched a little bit higher and lower. Okay, so let's just go ahead and sketch the graph, and we'll come through the origin at 90 degrees. You can look at it this way if you want to kind of check yourself out. What is sine 90 degrees again? What's sine 90 is 1. So it's really like saying 4 times 1. So if I input 90 degrees into this, I should get an output of 4. So that gives me an ordered pair to plot through. That makes sense? And we've already said that once I hit that point, I should be coming through 180. What's sine 270? All right, so 4 times negative 1, input 270, output negative 4. And then, I didn't hit it really well, we know that we should be going through 360. That's a big dot there. And then this is really all you need to do. You don't have to, I just want you to go through 360 degrees. All right, any questions? So we've done basically one complete period. When we get back to 360, that pattern just repeats itself. Okay, well, let's take a look at when there is a number in front of theta being multiplied. So here's what this is saying. First of all, what is the amplitude? Okay, how do I find the period? Okay, I don't know if you heard that. You do 300, you always put 360 on top, and then you divide by whatever this number is. So here's essentially what that number is saying. there's going to be 3 different cycles of 120 degrees within the 360. So we should see the pattern repeat itself that many times, 3 times. And then when we get to 360, we should be able to see that. All right, so let's just go ahead and come up with some theta intercepts. So we know 0. What's another one? 60? Okay, do you see how we got 60 degrees? You just always, for sine, you always do 1/2 times the period. And then what's another one? 120. And then after that, you pretty much see the pattern and you can just keep repeating it. All right, so what I typically do, and you may or may not need to do this, but now that I know where I'm going to be crossing the theta axis, I'm just going to go ahead and break this up into equal units of 30 each. My red marks represent 30. 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. Okay, everybody with me? Because according to my theta intercepts, I should be, maybe I'll change color. I should be crossing here and here. So it looks like, starting at 0, I'm crossing every other tick mark. Can you see that? I've started a pattern here. Cross here, here, here. So I'm just going to go ahead and lay it out. Every other tick mark, I should be crossing the theta axis until I get to the end. And so now I just connect the dots. So I'm going to come up through the origin and basically reach, well, I'll just go ahead and put amplitude. I didn't draw the amplitude. Amplitude is 1. I reach 1 right above this tick mark, and then I come back down through this one. Okay, at the bottom of 90 degrees. Need to go down lower. I come back up. And you can kind of check yourself. Once I got through 120, I should have completed 1 cycle. And the cycle should repeat itself. Can you tell that that's what's happened? All right, if you start at 0, 0, okay, I'm back to square 1, as it were. Now I'm going to repeat that cycle again. Okay, there's 2 cycles. And the third one. And I'm just going to show it. It's not going to go forever and ever, obviously, but I'm going to put an arrow just indicating that that cycle is just going to keep repeating itself. What do you think? It's pretty easy? Not bad? Any questions so far? Okay, let's do cosine. Very similar. The theta intercepts are going to be a little bit different, so we'll talk about those. The way we get amplitude is the same, obviously. The amplitude in this case is just going to be 1. What's the period? 180. And I went ahead and I gave you a formula for calculating intercepts for cosine. This time it's going to be 1/4. And if you're wondering, where are these numbers coming from? Where's the 1/4 and the 3/4? Well, let me just back up for just a second. Let's take a look at the parent of cosine. Do you notice that for the parent, I'm crossing 1/4 of the way and 3/4 of the way? That's where those numbers are coming from, if you're wondering. And for sine, I'm crossing halfway. Well, starting at 0, I'm crossing halfway. That's why we multiply by half. And then I end at whatever the period is. So, in case you're curious. Okay, so back to this problem. Give me a couple of intercepts. What is 180 divided by 4? Okay, so I'm going to be crossing at 45 degrees, and 180 times 3/4. 135. That's just helpful to get a good sketch of what this looks like. I'm going to label the theta axis. And since I know I'm going to be crossing at 45, to me, again, you may not need this, but you might want to make smaller units, like these represent the halfway point. This is 135, just making my way down the theta axis. Here's my amplitude. So let's get started. Cosine 0 is 1. So remember, cosine has this y-intercept of 1. Sine will go through the origin. So I'm just going to show that. I'm supposed to be crossing the theta axis at 45 degrees, which means down here I will bottom out just below 90 degrees. Then I'll come back up, crossing at 135. And now I'm just crossing every other tick mark. Okay, so verify, do we have 2 cycles? So the ending of one cycle would be there, and then that cycle repeats itself, stopping at 360. 2 cycles should be shown. Wow, that's a good one. Helps to be an artist, I guess. That's a good one too. Any questions? We just got one more, and then I'll give you the rest of the time. 2 more. I'll give you the rest of the time to work on this. So what's the amplitude? 1/2. Period. 120 degrees. Everybody see where we got 120? Always put 360 on top. Now for cosine, what will be my theta intercepts? 30 degrees, 90 degrees, and more, but that gives us a good look at what the pattern's going to look like. Here are my degree markings. You multiply by 1/4 and 3/4 times the period for cosine. Yeah, for sine it's 0, and then the period times 1/2, and then the period for the theta intercepts. Okay, so once again, to me, just to be nice and neat, I'm going to make these in 30s, 30, 60, 90, 120, 150, 180, 210, 240, 300, 330. And I'm going to show 1 and -1, but the actual amplitude is 1/2. So really, sometimes you'll see this, you'll see graphs that have this dotted line. And if you want to do it, that's perfectly all right. Just make sure you don't go below. All right, let's sketch. I'm going to go with a different color. All right, so we're crossing the y-axis this time at 1/2. I'm supposed to be, I have an intercept there at 30, which means I'll bottom out at 60, come back through 90. So basically it amounts to what we looked at earlier. I'm just going to hit every other one. And just verify, do we have 3 cycles? So at 120, that's a cycle. 240, 360. Any questions? Okay, I'm going to do tangent, and then this will be it. Ooh, better hurry. What about the amplitude for tangent? Be careful. Does tangent have amplitude? Yeah, so don't be tricked. Tangent doesn't have amplitude. It never stops going up or down. Remember the period for tangent. It's 180, and this time we're just dividing by 1. We would do the same thing, but in this case, dividing by 1 just gives us 180. Now, I gave you a formula here for tangent on how to find those asymptotes. Okay, I'm going to go ahead and label our typical 90, 180, 270, 360. And so if you want to know where the asymptotes should be drawn, this means we're going to do odd multiples of 180 times 2 times b, or 180 divided by 2 times b, and b again is 1. So where is my first asymptote going to be? 90. And do you understand what I mean by odd multiples? 90 times 2 would be an even multiple, so I need to do 90 times 3. And this one's a lot like what we looked at for the parent, but when it's not exactly like the parent, you can always do this little formula. Odd multiples of 180 divided by 2 times b. All right, and I'm just going to go ahead and do a negative 90. Okay, and so really all you have to do is make sure you cross where tangent is 0 and follow the asymptotes for the rest. Not really. I mean, it would give you more exact points on this, but we're not getting that precise. We're just doing a rough sketch. With all of these. So the thing you have to be careful with is, this is my last example, but just pay attention if you do have a number in front of theta. That's going to change where your asymptotes are going to be. That's your assignment.